You've likely encountered a situation in Excel where numbers appear to be stored as text. Now, there could be a few reasons for why this is the case, but you can solve this issue by running a special operation that converts the textual data into actual numbers. And a lot of you may know how to already do that. Now, this same thing can happen within polars where you have numbers stored as text. And the question is, how do we solve that issue? How do we get them into a correct format so that we can actually work with that data? And so that's what we're going to be showing you today. As always, I want to invite you to go get the Jupyter Notebook associated with this video on the Polars Codecademy repo. You can find a link to that in the video description. Also, Polars enables users to quickly perform complex data operations. The trouble is that when you're new to Polars, all of it may seem a bit overwhelming. The videos I put out here may help you along the way, but you could learn much quicker with the Polars Power Pack. The Polars Power Pack gives you over 40 Jupyter Notebooks that guide you towards mastering the Polars library. I'm currently expanding the Polars Power Pack, which means that the value of your purchase today will appreciate over time. As new notebooks and resources are added, you'll get access to all of those updates, and you can get those completely free. Follow the link in the video description and use code PCA20 at checkout to get an additional 20% off. Okay, let's dive into this now. So you can see that we've got our Jupyter Notebook pulled up here, and we have two main ways that we're going to be converting textual data into numbers. The first one that we're going to talk through is looking specifically at integer values. So you can see here we've got a data frame that we're creating. Let's just add a few more just on the fly, just so that we have a little bit more to work with here. But this is going to be our data frame, right? So this is going to be our textual data. Let's actually just do a little bit of editing here. I don't often do this while recording, but just to kind of show you. So we've got our number column for our new data frame that we have here, and it's stored as string values, and you can see that with the quotation marks around these numbers. Now, in order to convert these, and these are largely integer values, there is one decimal value here, and we're going to show you kind of what happens when you have decimal values. But the way that we can do that is using the toInteger function. Now, this is a string expression, so it only works on strings. So that's a little caveat there. So you'll call the string namespace, and then you'll say toInteger. And then this function does have some additional things that it can do, right? So the main thing that we're going to be using it for today is converting integer values into actual integers. But there is this concept known as base numeral systems, and there are multiple base numeral systems that you can convert from. So in addition to base 10, which is basically human readable numbers, there are other base systems that you can use, such as hex and binary, and so you can convert those types of textual data into integer values as well. So quick caveat there, that is something that's really cool that you can learn about. That is in the Polars Power Pack if you want to take a look at that. But again, today we're just going to be focusing on the conversion from text that is an integer into an actual integer. So that's what we're doing here. We're using base 10, and then, excuse me, we are going to pass strict here. So you'll see kind of what that does. But let's go ahead and run this, and you can see our conversion. Okay, so we have a new column here now called parsed, and it is an integer value. So you can see that we've got some successes here with this column, or excuse me, with this row and with this row, but our decimal row is not working quite right. Now, we can use a different function that will help us with decimals, and we're going to dive into that right now. So let's go ahead and expand this. And let's talk through decimals just real quickly on kind of a more conceptual level. So within computing and within databases, there's these concepts known as precision and scale. Now, precision is basically the entire length of the number, right? So that includes the decimal places and the actual integer values. And then scale is specifically the portion after the decimal point. So that is basically the decimal values. Now, why this is important is polars will have different behaviors when you try to, when you try to convert numbers with differing scales and differing precision. So first, we're going to show you an example of how to use uniform precision and scale and kind of show you what that looks like with the 2-decimal function. And then we're going to dive into more of those complicated situations that you need to kind of be aware of and look out for. So let's go ahead and first start with this uniform precision and scale. So we do have, yet again, we've got another data frame that we're just passing in here manually. And so we've got a few decimals, and it looks like they just have one decimal point or one value after the decimal. So this is very uniform, right? Let's go ahead and run this. We're calling the string namespace because this is a string expression as well. And then we're calling 2-decimal in order to do this. So let's go ahead and run this. Okay, so we have our string column originally, and then we have our brand new decimal column, and you can see it's got the decimal data type. Now it does have an asterisk here, and then it has a 1. So this is just to indicate the entire number, and then this is to indicate the scale here, right? So this is precision, and then the scale here. Okay, so this is very straightforward. It parsed it successfully, and you can see that we've got perfectly the values that we wanted there. But now we need to answer the question of what happens when you have mixed precision and scale. And you can do it. That's the important thing to know. You can do it. But the most important thing to note here is that the largest scale is going to become the standard for what the scale is for everything else, right? So if you don't have the same scale across all variables, across all numbers, then it's going to add some zeros to the end of that so that it meets that full scale. So we're going to show you what that looks like here. So we've got a few different decimals here that we want to convert. And you can see this one has a long scale. We'll use that term scale here, right? This one has a long scale. This one has a shorter scale. And then this one's kind of somewhere in between, right? So, and it's important to note too, I added some negative numbers here too to kind of show you that behavior, to show you that does work as well. But let's go ahead. We're going to once again call the same function, the 2-decimal function, and we're going to see what this does. Let's go ahead and run this. Okay, so you can see it's a little bit different. Obviously, it's got those mixed types together. It does set the scale to the one that's the biggest is going to be the main one that sets it for the rest of them. So for these other values that don't quite meet the 12 scale, it's going to add some zeros. So once again, now we have some functional numbers that we can work with, but there's just not as much uniformity here. So that's one consideration when using this 2-decimal function. Now we are going to also talk about inferring the scale. So as you saw, it was able to go through and it was able to infer the scale for each of these values. And it did pick the highest one, but there is another portion to this that you need to be aware of. When it comes to inferring the scale, it is only going to scan the first 100 records. Now this works if you just have a few of them that you're working through, but if you have thousands of rows or even hundreds of thousands of rows where you need to convert this textual data into numbers, you're going to run into maybe some issues with how that works unless you set the scale correctly. Now, unless you set the inference correctly. So that is to say that, again, the default is 100, but you can adjust this to be whatever you want. So in our case here, we've got some more numbers that are obviously decimal numbers with differing scales, right? You'll notice that we placed the scale here at the front, the lowest scale, and then we're going to actually test out and show you that if we just set this to 1, it's basically going to only evaluate that one record. So in theory, and we'll see this play out in just a second, this will be the scale that we see because it's only looking at that first value, which means, once again, it'll still work, but it will truncate the rest of these here, right? So let's go ahead and run this to show you that. So there you have it. We've got the correct scale of 2 because that's what we wanted it to look at. And so it also truncated the rest of it here. right? So that's another thing to be aware of, is when you infer the scale, you can customize that. Now, and I don't know if this will be released on a later version. It would be kind of cool if pullers added a functionality or a parameter here to basically have you dictate what the scale should be. I think that would be a really cool feature, because rather than trying to just go off of the largest or whatever, what if I said, hey, I just want to have a scale of 1? I just want to only have this portion, right? I think that would be a really cool feature. Obviously, it's not out yet, but who knows? Maybe they'll add in something like that. Okay, let's talk through the last concept that's really important when you use this 2-decimal function. So there is a maximum on the precision that you can have, and that limit, as you saw here, is 38. Now, this limit of 38 is pretty common in database management systems like SQL Server and others. There are some database management systems that have higher precision, and those are generally used for maybe more computationally important, where it's super important to have a lot of precision. There is some more flexibility there. Pullers does 38. That's pretty standard for SQL Server and different database management systems you might work with. There's very few use cases, I think, where having precision greater than 38 is really necessary. Maybe if you work for NASA and you need your calculations to be that precise, you might want to use something else. But this is a concept that we need to go through. So being that the precision is 38, that means that all of these characters that you see, all of these numbers that you see here can only go, there can only be 38 of them on either side, right? So in this case, what I've done is I've gone through and I've made sure that there's 38 numbers on the scale. So this is the scale side showing 38 numbers. Now that is the limit. So let's show you what's going to happen when we actually run this, and then I'll kind of explain what's going on here. So again, what I did was I set the scale to 38 by just having this entire decimal number place put out this far. I put it out 38. And so what happened was, even though this scale is much less than 38, and the entire thing is less than 38, it was looking for a scale of 38, right? So what that meant was this is not going to be successfully parsed because it doesn't accept anything before the decimal place. And so that's another thing to keep in mind if you have mixed types like that. And this is maybe more of a smaller thing, but it's important to kind of test these limits and show you kind of how it works. If you wanted to make this work, you could delete some of these. And if we run that, you can see we still have a massive scale of 24. But this one now is able to be successfully parsed. So those are kind of some of the limitations on this. All right, that is all we have for this video. We'll catch up with you at the next one.